let's take the degree of P of X, the numerator is greater than degree of H of X, the denominator. Of course, here X or N. Okay, degree of the numerator is greater than degree of the denominator. Let's take an example here again. And by the way, it works for all other degrees like the example, as long as the numerator has a higher degree. So evaluate the limit of, let's say here, 3x cubed minus 2x squared plus 4x minus 2 over, let's say here, 4x squared minus 2x plus 1. Okay? Of course, here I mean n and always write x, but let's do it for x. In the next course, we will work with real numbers. But here it's the same, okay? Just write n, whatever you have x. Okay? Now here the degree, obviously degree of the numerator is 3, degree of the denominator is 2. Okay? Now what is the highest exponent here? Highest exponent of both, it's equal n to the power 3. I hope it's clear for everyone. You look at the numerator, denominator, you identify the highest exponent. Then you divide by it, okay? Divide everything by n cubed. So this will become the limit of 3n cubed by n cubed. Then you have here 2n squared over n cubed plus 4 over n cubed n minus 2 over n cubed. Down here you have 4n squared over n cubed minus 2n over n cubed plus 1 over n cubed. And again here, this limit n approaches infinity, and this limit expands here. I am not going to write it, but it means here this limit will be evaluated, this limit, this limit. This is because of the properties of the limits. It's possible to do it. Now let's see what we get here. So obviously here we will be getting, if we apply the limit here, so here n squared, no, here we get n squared, here we get 4 over n. Okay, so here I got this simplification as follows. This is equal to the limit of 3 minus 2 over n plus 4 over n squared minus 2 over n cubed over 4 over n minus 2 over n squared plus 1 over n cubed. Then I expand the limits here. Well, what we will ultimately get here, this is 0, 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 this is 0. So ultimately I will be getting here 3 over 0, and it is infinity. So in general, when you have the numerator degree is greater, you will be getting infinity. You will be getting infinity. This is the second case. I hope it's clear. Any questions regarding this case? Oh, I have the mouse here. Any questions regarding this case? Okay, so we have now the second case. We are left with the third case. Third case, it says simply the following. It says 3 degree of the numerator is less than the degree of the, let's say, okay. So we said that degree is a number comparing two numbers, either one is greater or smaller or they are equal. These are the three cases because of the ordering property we saw earlier in chapter 1 with the real numbers. Now, let's take an example again here, and maybe we take something similar to the previous example, but with numerator and denominator switch. Let's say here, for instance, 4x squared n squared minus 2n plus 3 over first limit n approaches infinity. This is how it reads. And here, let's say 3n cubed plus 2n squared minus n plus 5, let's see. Okay? Obviously, here n degree of numerator is 2, degree of denominator is greater, is 3. Again here, highest term of both is n cube. So divide by this, divide everything by n cube. Let's see what we get here. So this is equal the limit of 4n squared over n cube minus 2n over n cube plus 3 over n cube. This is all divided by 3n cube over n cube plus 2n squared over n cube minus n over n cube plus 5 over n cube. And this is, of course, as n approaches infinity. Okay? Now, let's see. Here we have, we end up with having 4 over n, this one n squared, this one we have just 3, this one here we have n, this one we have n squared. Okay, so this is the limit of 4 over n approaches infinity, minus 2 over n squared plus 2 over n cubed. And here we have 3 plus 2 over n minus 1 over n squared plus 5 over n cubed. Okay. So obviously all these limits where we have n in the denominator or n squared or n cubed, they will go to 0. This one will go to 3. Okay, so here we have 0 over 3, and this is equal to 0. Notice that in the previous two cases, we didn't give 0, we didn't get 0 over 0, because getting 0 over 0 is really a big problem. But if you get 0 in the numerator and the constant in the denominator, or the other way around, it's not a problem, because it's different than getting 0 by 0. 0 by 0 is, in mathematics, is called indeterminate value. However, the value over a constant or a constant over 0 is defined and it can be evaluated. So this is an important difference. So 0 over 0 is always, in terms of limits, it's always a problem. Okay, so these are the three cases. And after we get back from the holidays, we will get more examples. For instance, this morning we had the problem. Now sometimes you can solve it using different techniques. For instance, if you have, I don't know, evaluate the limit of let's say 2n plus 1 over n as n approaches infinity. Now here these are polynomials with, okay, these are two polynomials. Let's say this is degree 1, this is degree 1, and obviously you can divide by n, okay? Or you can just simplify it, okay? So this is equal to the limit of 2n over n approaches infinity, plus the limit of 1 over n approaches infinity. So this will cancel out. So you have here, it's equal limit of 2, n approaches infinity, plus the limit of 1 over n approaches infinity. And this is equal 2 plus 0, and this is equal to 2. Okay, this is one way to do it. Or you just use the same technique we used before, and then you divide everything here by n. So you end up of having, of course, the same. So wherever you have same degree, then you end up of having the coefficients. Let me just give you an example here. If you have, maybe this is a little bit complicated example, or it looks complicated, but if you have here n to the power 79 plus n to the power 59 minus, I don't know, 3n to the power 37 plus n to the power 21 minus n to the power 15 minus n cube over, let's take here 6, for instance, and here you have 2 n to the power 79 minus n to the power 58 plus 3n to the power 44, for instance, minus n to the power 37 plus 5n to the power 17 plus n to the power 11, for instance. Okay? You see, if you are asked to evaluate this, no problem, you use the same technique like before. So the technique we used for equal. So here you have these degrees of the polynomial, both polynomials are equal. Then you do the same, you divide by n to the power 79, and then you will end up of having this coefficients times divided by this coefficient, because you will just reduce this to these coefficients. So here at the end, you will be getting 6 over 2, which is equal to 3. You see how simple is that? Now, if you add here n to the power 80, then you divide by n to the power 80, you will be getting 0, or a number over 0, so it's infinity. If you have here n to the power 85, for instance, then you divide, then you will be getting 0 over the constant, which is 0. So you have, in the second and third cases, you get infinity or 0. In this case, you get the coefficients of the numerator, highest coefficient, divided by the highest coefficient of the denominator. Okay, so I think this is all you need to know. Be careful to understanding if you have a sequence, how to find out its geometric or an arithmetic sequence to evaluate, to construct the general term. You will be giving the formulas. So for the mock exam on Wednesday, you will be getting the formula sheet, and you are allowed to use non-programmable calculators. And yes, we will have a look at the answers after. So I will assume that by 8:30 at the latest, we will start until 10, for 1.5 hours. And let's see, many students are asking whether it's going to be counted or not. This is trial exam. It means it has absolutely no effect on the directly. I mean, it might, if you study and you take it seriously and you will understand, then you will be getting better grade, of course. But in general, it is a big problem if you just, take it easy and then you don't study and then you will face the problems in the final. So please take it seriously. Try to read the script, try to solve the worksheets, understand what the solutions there. I uploaded even the worksheet we had this morning. The answers are there. I will be uploading this chapter immediately now after the class, and then you have everything you need for the mock exam. Mock exams do not count at all, okay? But it's important for you to take it seriously, to know where you are standing, to know what you need to improve towards the final that we will be having at the end of, I don't know, this semester, maybe either late January or early February. And then polynomial, this one, last one. Yes, you do have. No? And by the way, since you asked this question, now if you have, let's assume you got this assignment, square root of the limit of the square root n approaches infinity of, let's say here, 8n squared minus 2n plus 3 over 2n squared plus 5n minus 1. Okay? What to do here? Then you will evaluate this amount here. So you can, according to the rules here, you can insert the limit here inside 8n squared minus 2n plus 3 over 2n squared minus plus 5n minus 1, n approaches infinity. And if you evaluate this to equal, so then you will be having here at the end the square root of 8 over 2, which is 2. See how simple is that? Okay, if you have equal polynomial degrees, then it is the coefficients divided by each other. You can take the limit here inside the square root. Now, if sometimes you have to be careful. It's not arranged. For instance, you might be getting, I don't know, n squared minus 3n plus 4 over 2n plus 1 all squared. Okay? Then you need to expand this one and then apply the rule. You know, the mathematics, I teach you how to get from A to B, and sometimes you need to make up your mind how to get to A, where you know how to proceed from there. So this is, that's why it's called analytical principles, okay? But Muhammad, I don't know why you're asking. Is it that complicated? It's straightforward. 3 cases, you have same degree, like in these examples, you have different degrees, and you have different degrees means 2 cases. One is on the numerator is larger, or in the denominator degree, but always divide by the highest term and make use of the fact that the limit of any, so here I'm not going to include other than these 2 limits. You need to understand that the limit of a constant is equal to the constant, of course here n approaches infinity, and the limit of anything like, let's say, 1 over n to the power k is in R, is always equal to 0. Okay? Or actually it's not k here, you can take any other constant also. because in the denominator it increases. So if you know, as you go from 1 to 1 over n, the n increases here in the numerator, it means it gets close to 0, the whole amount here. These are the things you need to know, and the techniques I told you about, and you can master any of the questions there. Okay. There will be a question regarding this. There will be a question regarding how to find out arithmetic and geometric sequence. For arithmetic sequence, you just subtract successive terms. You have D, you have the first element. Then you apply the formula. For the geometric sequence, you divide the next term by the term before, and you get Q, and then you need also the first element. And by the way, the last question in today's worksheet, if you can just can go to the worksheet, the interest rates, you have two ways to calculate the interest rate. One is following just the arithmetic sequence, where we put the simple interest, where you just have add each year a certain amount of interest to the starting principal. And the other is the compound. That means you will get money in the first year, and this will be added to the principal amount, and then it will be for the next year not only the principal amount, but the amount of the interest that was added in the first year, and so on. That's why it's called compound interest. And this follows the you can have a look at the solution of the worksheet. It follows the geometric sequence method. And very important is that the compound, you get more. Okay, in this example, you see that the compound interest rate, it will after 5 years, I think that was the example, you will be having